welcome back to my YouTube channel. So today's presentation is about introduction to directional derivatives and application. So this is the introduction page. Introduction to directional derivatives and application. Directional derivatives measures the rate of change of function in a specific direction. They are useful in optimization problems where we want to find the direction of the step-based ascent or descent. Directional derivatives are calculated using the gradient of the function and a unit vector in the desired direction. So here you can see the example. Directional derivative f of x comma y is equal to delta f of x comma y into v. Here v is the unit vector and delta f of x comma y is the gradient. Let us see. So definition of directional derivative. The directional derivative of a function f of x comma y at a point P in the direction of unit vector u is equal to ai plus bj is given by delta f into u, where delta f represents the gradient of the function f and dot denotes the dot product. The directional derivative provides the rate of change of a function f in the direction of vector u at a point P. So here you can see the example. Directional derivative of f comma x is equal to fx of x comma y cos theta plus fy of x comma y sin theta. So this is theorem. Computing directional derivatives. To compute directional derivative, first find the gradient of function f of x comma phi as delta f is equal to df by dx whole per into I plus df divided by dy into j. Next, normalize the directional vector to obtain unit vector. Finally, calculate the directional vector delta f into u to determine the rate of change in specified direction. First, in order to solve this directional derivative, you need to differentiate the function x comma y. So df of dx means you have to differentiate with respect to x, and next df of dy, the f function you need to differentiate with respect to y. So when you differentiate the both vector and multiply with the unit vector I and j, you get an equation. So that equation you have to multiply the delta f, have to multiply with a unit vector. So unit vector is nothing but cos pi by 4 comma sin pi by 4. Here in this problem, in this picture, they have given that directional vector z is equal to x square minus 2y square at a point 3 comma 2 comma 1 in the direction theta is equal to pi by 4. So in the previous slide I have explained you that this f of here, this is the formula. The f of x comma y is equal to f of x comma y cos theta plus f of y of x comma y sin theta. So using this formula, first you need to differentiate the first z vector, uh, differentiate with respect to x and differentiate y with respect to y. Then you get a equation. Then that equation you have to multiply by cos phi by 2 and sin phi by 2 using this formula. Next, interpretation of directional derivatives. A positive direction derivative indicates an increase in the function value in given direction. A negative directional derivative implies a decrease in the function value in specified direction. A zero directional vector means the function is constant in the direction at a given point. So the positive directional derivative indicates that increase in function value. If negative directional derivative is given, it indicates the decrease in function value. So if zero directional derivative indicates that it is constant, the function is constant, there is no increase or decrease in the function. Next, application of gradient descent. Directional derivatives are crucial in optimization algorithms like gradient descent. In gradient descent, the negative of the gradient points in the direction of the steepest descent. By updating the position based on the directional derivatives, we can find the minimum of the function. So, as you can see, this in this picture, it is more suitable for best convergence of this scenario. Applications of these directional derivatives in physics. Now let us see what are the application in physics field. In physics, directional derivatives are used to calculate the velocity and acceleration of particles moving along curved path. Then the directional derivatives of position vector gives the velocity vector and its derivative yields the acceleration vector. This application helps in analyzing motion in various directions. So here mainly it is used to determine the velocity and acceleration, especially when the particle is covering the curved path. So the direction gives the velocity and the derivative gives the acceleration. So at a time you can find both velocity and acceleration keeping position of an object. So in this example here you can see the position of the object is moving in a curved path with respect to time, and the velocity is in a straight line, and the acceleration is horizontal to the time, which is parallel to the time. So in this way we can determine both acceleration and velocity keeping the position. Application in economics. In economics, directional derivatives are valuable in studying production functions and utility functions. The directional derivatives helps determine how changes in input variable affects output or utility. This analysis aids in decision-making processes related to resource allocation and optimization. So it is mainly used in valuables in studying product production function. Next, application in engineering. Engineers use directional derivative to analyze stress and strain distribution in material. By computing directional derivatives of stress or strain function, engineers can identify critical points and design structures to withstand loads. This application ensures the safety and efficiency of engineering design. So exactly it is helpful in maintaining the in determining the stress and strain of a material. Determining stress and strain of a material is very important in order to make a good product or a good surface. So it is useful in engineering field also. Limitations of directional derivatives. Directional derivatives may not exist if the function is not differentiable at a point, or if the direction is not well defined. So in order to have proper solution for a directional derivative, it should have a proper differentiable point and it should have a proper direction. If there is not a proper differential point, or if it's not in proper, if you have not mentioned the direction, then we'll not be able to solve this directional derivative. So both should be defined. So if not defined, we can't solve. So that is one of the limitations of directional derivatives. So here in this problem also I can see they have given the directional derivative f z, and they have given the points and they've given a direction. So everything is defined, so we are able to find the solution. Next, in some cases the directional derivatives may vary depending on direction we choose. So direction derivatives problems, like for the same vector you'll find different answers. That is due to the change in direction or the direction we take. It is essential to consider these limitations when applying directional derivatives in real world problems. So it is essential, we have to consider these limitations also in order to solve the real world problems. So what is the conclusion? Directional derivative plays a crucial role in analyzing functions in specific direction. They are used in optimization, physics, economics, engineering, and various other fields. Understanding directional derivatives enhances problem solving skills and enables better decision making in diverse applications. So it is used in various fields. It is used to calculate many things. So directional derivatives is one of the most important topic in mathematics. So understanding directional derivatives helps in problem solving skills, enhance better decision making in diverse application. As we have seen in engineering field, in order to make a product or something, it is very important. And in also in physics field, in order to measure the velocity and acceleration easily, we can use directional derivatives. So understanding this is also very important. So here are some examples of directional derivatives. You can go through it. So thank you so much for watching my video. If you like this video, please do like, share and subscribe.